Hello and welcome to this section, Graph Database and Neo4j. In this section, we will see some benefits of using Graph Database over the traditional database. Primarily, we will be covering the comparison between relational database and Graph Database. Also, we will start some practical work with Neo4j as well. From this section, we will cover working with nodes and creating some relationships between the nodes. Along with that, we will start our project that we will be covering in our course. This video is actually about relational databases versus the graph databases. I will try my best to teach you why choosing a graph database is best for your application or your project. I will also get you know about the comparison between the relational database and the graph database. So let's see why choosing a graph database is best over the relational databases. Since we all know that we store relational database in the form of tables, and the tables are built using some primary keys, we also define some data types to store the data into those tables. But here in graph databases, we have no headache of creating the tables, creating the primary keys, and defining their data types. We all do that dynamically. It means user can define the type of data at runtime. The handling of relationship is very smart in graph databases and Neo4j. When we add the data into some different type of data in the database, we need to change the schema of the whole database. But here in graph database and Neo4j, we have no issue with that. We will keep working with our same database and with the same schema that we have for our project. And the performance remains the consistent along with changing and adding the new data. Since we all know that in business, we follow the agile methodology. It means the requirements change instantly. And if we are working with Neo4j as a database, then we have no issue with changing the business model, although it will not affect our whole database. This is how graph database is having a great impact over the relational databases and is more beneficial in working with that. Comparison between relational database and the graph database is that, as I explained, we use tables in relational database to store data. You can see we have an entity student and it has three attributes: ID, name, and date of birth. We also specify the data types for these attributes before storing the data into the table. The data type of ID, name, and date of birth could be integer, string, and date respectively. Whereas for the student node in graph database, we don't have to define the data types at before creating the data. We need to define the data types at runtime, and database automatically gets the data type according to the data that we have entered for the saving into database. Now coming to the columns of relational database and key value pair of nodes. Since we know that the data is saved in row-wise, but the columns provide support for identifiers in order to find the data type of the data in the table. We have a student table with three attributes: ID, name, and the date of birth. We are bound to store the data of integer type in ID column. Name should be string and the date of birth could be of date or string, but we must have to define before saving the data into the table. Now coming to the node, we see that we have ID as ABC-123. The data type of ID could be anything according to the user. For the name, string commonly that we use, and for the date of birth, we can use date or string. But it's on the user what he selects. So no worries about the selecting the data types and defining the column names for saving the data into the database. Now coming towards the constraint that enforce the rules on tables and sometimes on columns as well, that ensures the accuracy, reliability, and the integrity of the database. You may have experienced using common constraints like primary key and defining the foreign key and some other constraint like the column should not be null and some default values for the columns. Now, and coming towards the graph database, we see we do not have a headache of using and defining the constraints before saving the data into the table. Although we use relationships here, ensures the integrity of the data and doesn't affect on deleting any node from the database. But when we delete any data from relational database, we must have to check either it is exported or as a foreign key somewhere. If that is the case, we need to delete from that table and then we can delete it from the current table. This is the advantage of using graph database over the relational databases. Coming towards the join, which is the main torture for the users to select the right join for getting the right data from the table. But here in Neo4j, we do not have any issue of using joins. We just select the data using the relationships between the nodes, and that's how we work with Neo4j. You may have experience on selecting the joins like inner join, left join, right, or full. It can be of either any type of the join. You also see the syntax for getting the data using joins is very complicated and very tricky to understand. But here in Neo4j, Cipher query language helps us, provides a very simple syntax in getting the data from the database.